Okay, due to popular request and consistent nagging, I will do this function transformation question. It's a little thing they've added. This is kind of like a part 2 to the functions question, which is like one of my most popular videos. So I'll put a link for that in the description, but you should watch that first. But look, I mean, we have these functions and we can move them around, we can stretch them and we can flip them. We can reflect them, and that's really all this is on. It's just getting you to do stuff with that. And so I've made this worksheet from, because it's new, it's just 2020 questions and some from 2021 and new specimen papers. I've extracted them all there for you, and I've gone through and answered them all for you. So that's that. You can download that in the link in the description. Okay, so yeah, let's go through a little bit of theory, then do some questions, and understand what the hell they want from us here. Okay, I'm gonna take a puff of my vape. Okay, so we have these things called functions, and we can do stuff to them. We can transform them. So we can shift them. So there's a few things we can do. We can shift them. So let's say we have some function, and I'm going to use, so this applies to all the functions that they can give you, and you can test them out. There's actually some cool software called Demos, which you can look up online, which will help you visualize these things. But look, I mean, let's say we have f of x, right? Let's say this is equal to x squared. So that looks like this, right? So what would f of x plus 2? So this would be shifting it in the y direction. We'll be shifting this thing in the y direction. So let's say y equals f of x plus 2. Well, this just shifts this thing up 2. Look at that drawing. It shifts the graph up 2. So this is at 0, and now we're at 2. Because we're just adding 2 to every f of x value. Okay, and if we were to minus 2, well, that shifts it down 2. And this will become clear when we do questions, but I'll just do a little bit of theory here. Look, and then, so f of x minus 2, well, that just shifts this whole graph down 2. Okay? So we're just shifting up and down in the y direction. Or f of x direction, if you want to call it that. Okay, and what about if we wanted to shift it in the x direction? Well, what does that look like? Well, let's say we plus 2 here. Well, you might say, well, doesn't that just shift it 2 to the right in the x direction because we're adding 2? Well, in fact, it doesn't. It shifts it to the left. And maybe that's counterintuitive to you. It doesn't make much sense, but it does make sense. Like if our input here is x and it goes to x squared, well, now our input here is x plus 2. So this would be x plus 2 squared. Well, what does this graph look like? Well, this graph is, well, our vertex point is at minus 2 and 0. So it'll be here, minus 2. So that's that graph. So as you can see, when we add here, and if I could call it A if I want, which I do on the worksheet. So you can look at that for all the theory. I'm just going to run through this quick. There's heaps of videos out there on this theory. But look, so this is shifting it in the left direction when we add x to this input here, to this part. And if we were to minus it, so let's say minus 2, well then this becomes, instead of plus 2, this becomes minus 2. And that graph looks like this, if you graph it. And I advise you to go and test these out on different functions, but this is the case for all the functions they give you, for the trig functions, for lines, like for all of them. Okay, like if this was x, you know, if this was x instead, well then what is f of x plus 2? Well, that just means x plus 2. So we have this y equals x, or f of x equals x here, like that. And then so x plus 2, well now this has just shifted it, our x plus 2 line. This occurs, well look, I mean, what does this line look like? When y equals 0 here, what will our x equal? Well, x will equal to negative 2. So that means it passes through this point. So that would be our y equals x plus 2. Okay, so, and again, so it shifted this line minus 2. Okay, people seem to get tripped up on that. It's just the opposite, and the reason for that is because of exactly what I showed you. Just sub them in and it will make sense. Okay, so that's like shifting. So we've shifted, we can shift it up and down, and we can shift it left and right. Okay, we can also stretch. So maybe I'll use a different function. Let's say, I don't know, sine of x. I'll just use a different function to show you that, you know, it works for all of these functions. So sine of x, what does that look like? Well, sine of x looks like this. Like this, right? It goes from 1 to -1. Okay, so what would 2 of f of x look like? Well, this is just doubling the amplitude, right? So we're just doubling it in the y direction. So this would then go up to 2 and down to -2. Right, so this would be -2, 2. And if it was a half, well, this would half it. It would half the amplitude. Oops. Sorry if I'm going quick, but I don't want this video to be too long. That would half the amplitude, right? We go to a half and a -half. Right, and if you don't, that comes from they're just halving the amplitude. Right? So that would half the y direction. Now again, this might trip you up. This let's say if we wanted to then, so that's stretching in the y. What if we wanted to stretch in the x? Well, again, let's look at this sine graph. Looks like this. Well, so we have f of x equals sine of x. This is f of x. This is x. Well, now what would this look like? Well, this would be sine of 2x. And if you know about trig functions, about these sine x, well, that means that we halve the period. So this will look like this. Sorry for the bad drawing, but it's halving it. It's halving this period. So it's shrinking it by half. So that this line here is f of 2x. Okay, and this line is f of x, or y equals f of x. If you want to be super serious. Okay, but what about this? Well, this again will just do the exact opposite. So this is then going to double the amplitude. So it will look like, let me get rid of that. Let me get rid of that line. This one, so half of f of x, was going to double it, so stretching it by 2. So it's doing the opposite, kind of like the adding and the minusing. So this will look something like this, right? Okay, and it'll become clearer when we do things. And then one more thing we can do is we can reflect. So we have f of x, let's say, I don't know, equals, I don't know, x plus 2 squared. So that's going to be here, like this. So this will be at -2. Well, what is minus f of x? Well, this is just changing all of our y. It's flipping it in the y direction. So all of the f of x's points, they're now going to be minus f of x points. So, you know, all these points here now will go to here. So you could say it's reflecting in the x-axis. And if it was f of minus x, well, now we're changing all the positive x points, all the x points, to minus x points. So we're flipping that. So then we could say it reflected in the y-axis. So this would be a 2. So, you know, this is f of minus x, and this is f of minus f of x. Okay, a little bit of theory. Maybe I went on too long, but there is theory on there. I did it a bit more rigorously on there. But now let's jump into some questions. How they can sort of ask you these things. Or maybe I went on too long, but whatever, man. Whatever. Okay. So in each parts A, B, and C, the graph showed solid lines as equation y equals f of x. So we've got some function, looks like that, and the broken lines show the transformation of y as f of x. So state in terms of f the equation of the graph of the. So how is this f of x function transformed? Well, let's look at this. Well, this is simply reflecting through the y-axis. Okay, if it's reflecting through the y-axis, that means that all these points that were x, so this is, you know, x equals 1, well, this point now is at x equals -1. This point here is at x equals 2, well, this point here is at x equals -2. So our new one will be f of minus x. Right, we're changing all these positive x's to minus x's, or we're reflecting through the y-axis. I feel like this stuff is pretty intuitive. I mean, it makes sense to me. You sort of just have to think about it. Don't worry about remembering these things, just think about it. Okay, what about this one? State in terms of f, so same thing. Well, you might think, okay, we're shifting this up, but actually if you look at it, well, you know, we're actually stretching this in the y direction. You know, here our y was at 1, and here now it's at 2. Here this point is at y equals 2, well this is now at y equals 4, and here this point was at y equals 3, well now this point is at y equals 6. So we're doubling our f of x values, or our y values. So you can say this new one will be a 2 of f of x. So we're doubling all that stuff, right? So we've gone from f of x, and we've doubled all of these f of x values, or y values, however you want to think about it. So that's your new dotted line. Okay, what about this one? State in terms of f the equation of the graph shown with broken lines. Okay, well you can see it looks the same, it has the same shape, so we're not stretching it. Really all we're doing here, and it's not flipping anyway, so really all we're doing is shifting it down 1, 2, 3 in the y direction, and 1, 2, 3, 4 in the x direction. So what would the graph shifting it down 3 in the y direction? Well, this is just going to be equal to f of x, and with these transformations I would always recommend taking them one at a time. Well, we're shifting down minus 3. Right, we're going down minus 3. We're minusing 3 from all of our f of x values. Okay, and then we're minusing 4 here, and that would look like, well, because we're moving to the left, like I explained before, well, this is going to be x plus 4. Right? Like I explained above why that was. Right, because when you substitute this input in, it's instead of when we're plussing here, it's moving to the left, and when we're minusing, it's moving to the right. So that would be your final, that would be these dotted lines. Okay, so that gives you a little taste of some of the theory we went through. That was a question they asked one year. Okay, let's do one involving trig functions. Okay, so basically we have the curve of y equals cos theta, which is this thing. And the upper curve is a result of applying a combination of transformations to this original y equals cos theta. Find in terms of cos theta a cosine function, the equation of the upper curve. So we need to apply successive transformations to this cos theta in order to get it to that upper curve. So let's take it step by step. Well, first of all, I can see, so I'll just draw this cos theta out real quick. How many do they go? 1, 2. So it's like this, where this is 4 pi, and this is our y. 1 minus 1. Okay, so I can see here that they've stretched the period. I mean, in the x direction, we've stretched it by a factor of 2. Yeah, if we stretch this, we double this stuff. This will go here. This point will go here. 2 pi will go to 4 pi. Pi will go to 2 pi. So if this is y equals cos theta, well then y equals cos of a half theta, because we're stretching it by 2 in the x direction, meaning we half that thing, like I explained at the start. And you need to understand this, and this again just comes down to your understanding of trig functions. Well, this is going to look like this now, where this is 4 pi. This is 1 minus 1, right? And that is at 2 pi, which now has the similar shape of that top one. Okay, so now we've got to here. Well, let's have a look at this top one. Well, this one goes up 1 and down 1, but this top one, if you look at like the center, this goes up 2 and down 2. Okay, so we're doubling the amplitude. So we can look at this, 2 cos, because we're doubling the amplitude. Well, I don't even need to draw it. We'll just double this amplitude and go from 2 to minus 2. Right, that's now this graph. But that's not quite it, because also we can see that, we have to shift it up. So we're shifting it up by, if we're going from 2 to minus 2, we're shifting up 1, 2, 3. So 2 cos of a half of theta plus 3. We're shifting it up 3 in the y direction. So that will give us that final graph where it will go like this. Wait, what is it? Where this is 1, 5, and we got 2 pi, 4 pi. Okay, so then I've shifted this graph up, 3. This will go from minus to minus 1, 0, 1. This will go to 3, 4, 5. So we just shifted that whole thing up. So what I did there is I got the same shape, and then I shifted it to the same position. So then your final curve in terms of the cosine function is this. So just take it step by step. I stretched it by halving this theta. I then doubled the amplitude, and then I shifted it up 3 to get that graph. Okay, and the final one, so we've done something with lines, we've done something with trig functions, and now we'll do something with completing the square. Okay, so and you should have seen this before, express this in terms of this. Well, how I do that is I just say, okay, so let's first write this. Yep. So what I do is, okay, I just like jot this on the side. I go, okay, well, x plus 3 squared, what is that? That's x squared plus 6x plus 9. And then to get to this, well, I need plus 5, so I'm going to need to minus 4 on the end. So minus 4 to both sides. So this in the completed square form is x plus 3 squared minus 4. Okay, and that's helpful because it shows us where the vertex point is for this graph. Okay, so this is the same as this. So the vertex point occurs, so the minimum point of y will occur when x equals negative 3. So negative 3, and when x equals negative 3, our y will equal to negative 4. So this is a parabola, something like that, right? With the vertex point at minus 3 and minus 4, okay? And then it says the curve of y equals x squared. Actually, probably looks more like this. And then y equals x squared. Look at this beautiful drawing. This is y equals x squared. So this B. Sorry for this being messy. I just want to get through this quick because it's not a hard question. It just comes down to common sense, really. Okay, transformation. So we want to, how do we get from y equals x squared transform to the curve of y equals to this, basically? So how do we go from this curve to this curve? That's this curve. Well, this is at 0, 0, so we're simply shifting this function down 4 and across and to the left 3. So you can say you could translate, so you could translate curve by, well, minus 3 in the x direction and minus 4 in the y direction. Or you could say it in English, you know, you could say shift minus 3 in x direction, and then shift minus 4 in y direction. Okay, cool, and that's 3 good questions there. All done and dusted. Make sure you go download that worksheet. And before I finish, yeah, download the worksheet, but before I finish, I just want to say a couple things. This idea of function, I want you to stop thinking about these things, and this is important for you to listen to this. Function, this is not just in the context of mathematics. See, the thing is, in school they teach you this as some dry abstract concept within mathematics. This idea of function is massive. It constructs our entire society and culture. Maybe not culture, but our entire society. Look around you, you're literally drowning in real life functions. Meaning with something with a specific input for a desired output. That idea itself has literally governed our entire society. Look at business, look at your phone, look at everything around you. Look at me clicking, technology, everything. It's governed by these functions. Why should you be interested and should you actually think about these things outside of the context of mathematics? Why is that worth it? Because then you can start to understand what role these plays in your real life, even for you. Look at you. Do you not think, have you noticed that lots of people act and behave and think in similar ways? Why do you think this is? Because you yourself are a function of your society. You are the output. The input was that little baby, and the culture and society did stuff to you. They put you through education, you learned all this stuff, and then you became an adult, and now you're this adult, and here you are. And so you're in a sense, a physical representation of a function. These things are not dry mathematics. These things govern the world. Is it a good thing? Is it a bad thing? We're constantly trying to get these things to be more efficient. Think about business. We're trying to create efficient functions, efficient ways of producing mass things quickly and efficiently. And are we losing something there? If you want to achieve a goal in your own life, you're going to have to input something to get a desired goal, a desired output, a desired thing that you want. And you're going to do that through trial and error and find different ways that work. That's acting in a functional way, a robotic way. Are you losing some things there? Are you just a functional creature? I'm doing a little rant here because I want people who watch me to think larger than mathematics. These things are massive. These ideas are huge, and these ideas came first, and then the world that we see today is a formulation, a physical representation of these ideas. Look around. look around. It's great stuff. Anyway, that's it. Download the worksheet, brush up against that subscribe button, give me a fat juicy like, and for those people who are like, yo, why aren't you uploading? I'm uploading on Patreon. I've been uploading there for a lot of this year. I've uploaded my best content on there for Pure 3 at the moment, and I'll do more in the future. So if you want to grab that, you want to go over there and support me and get that content, you can. It's great stuff, and I love you all. Have a beautiful and wonderful day. Good luck for your exams. Peace out.